Giant industrial bearings begin with iron ore taken from the ground. Mining excavators collect large amounts of iron ore from the quarry. The mined ore is transported to crushing machines. Large rocks must be broken into smaller fragments.
The ore is dropped into powerful crushing machines.
Crushing machines reduce the size of the ore. Conveyor systems move the crushed ore across the mining facility. The crushed ore is collected and prepared for transport to steel plants. This iron ore will be transformed into steel, used to build giant industrial bearings. After the first crushing stage, the ore moves through additional processing machines. Vibrating screens separate ore by particle size. Cleaning removes dust and impurities from the ore. The processed ore is now ready for transport to a steel smelting plant.
The iron ore is transformed into molten metal inside blast furnaces.
Molten iron is collected and moved for further refining.
Refining removes impurities and creates high-quality steel.
The molten steel is cast into solid billets. Fresh steel billets must cool before further processing.
Steel billets are cut into manageable sections for transport. The billets are transported to manufacturing plants.
These steel billets will be used to manufacture giant industrial bearings.
Steel billets must be heated before forging begins.
The heated steel is shaped using powerful forging presses. Repeated forging shapes the steel into strong bearing components. The forged ring moves to a rolling machine to expand its diameter. Forged steel rings must be expanded to their final diameter. Rolling machines gradually increase the diameter of the steel ring. Multiple rolling cycles ensure the ring maintains its circular shape. The expanded ring will become the outer race of a giant industrial bearing. Heat treatment strengthens the steel structure of the bearing ring. The heated steel must be cooled quickly to achieve the required strength.
Rapid cooling locks the steel structure into a hardened state.
After heat treatment, the ring is ready for precision machining. Precision machining shapes the bearing ring to exact dimensions. Machining removes excess steel and prepares the raceway surfaces. Accurate machining ensures the bearing will operate smoothly.
After machining, the ring moves to the next finishing stage.
Grinding refines the bearing raceway to an extremely smooth surface.
Both raceways must be perfectly smooth and round.
The raceway must be extremely smooth for the rollers to move correctly.
The finished ring is ready for bearing assembly. Bearing rollers are machined from hardened steel rods. Rollers must be extremely smooth to reduce friction.
The cage keeps the rollers evenly spaced inside the bearing.
The rollers and cage are now ready for bearing assembly. The precision components are assembled to create the final bearing. The cage keeps each roller correctly spaced. Each bearing is tested before leaving the factory.
After testing, the bearing is ready for packaging.
Finished bearings must be carefully protected before transport. Protective coatings prevent corrosion during storage and shipping. Packaged bearings are moved to the shipping dock. The packaged bearing is now ready for transport. The finished bearing now leaves the factory for industrial use. Large bearings are used in many types of heavy industrial machines. These giant bearings allow heavy machines to move smoothly under extreme loads. This massive bearing is now ready to operate in heavy industry.